Okay, we're going to be doing lead code 744. Find the smallest letter greater than target. So we're given characters, an array of characters called letters that is sorted in non-decreasing order, which means ascending order, and a character called target. And we're supposed to return the smallest character in the array that is larger than the target. In other words, out of all the characters in the array that are larger than target, right? So for example, here it's all of them, so we return this, right? That's what you're supposed to return: the largest character in the smallest character in the array that is larger than the target. And the good thing is that it's sorted, so we can just iterate through. But there's also an extra condition here. They're saying that the letters wrap around. For example, if target is Z and letters are A, B, then the answer is A. What they mean by this is that, let me show you here in a sketch. What they mean by this is that usually they'll give you like a set of characters, right? Say A, B, and then maybe something like Z, right? And then they'll tell you find the character, the smallest character that is larger than F, right? So obviously when you're iterating from this side up until here, you'll find that Z is the smallest character larger than F, right? But there could be a scenario whereby your target is, say, Z, right? And the smallest character doesn't exist. I mean, there's not even, let alone the smallest character larger, there's no character larger than Z in this array, right? So what they mean by a wraparound, it will be something like this: A, B, C, D, Z, right? So what they're trying to say is that if all the letters in the array are smaller, right? If this is our array, and if all the letters are smaller than the target, right? Then that means that we consider the target smaller than the first. So that's what they mean by a wraparound. So in that case, if all of them are smaller, then we simply return the first one, which is at index 0, right? So let's solve this using a linear scan, right? So for character in letters, we're going to iterate through until we find a character larger than target, and we'll return that. This will work because the characters are already sorted, right? If they weren't sorted, we'd have to first sort them in n log n time in place, or if you want to do merge sort, whatever, and then iterate through. So if C is larger than the target, then we simply return C. The letters after C will be larger, but they won't be the smallest, and that's what we're asking for. But if there is a wrap around, then it means our target is larger than all the characters. It means it's larger than all the characters. So we consider it smaller than the first, i.e. a wrap around, right? So if we do not return any from within the array, then we simply return letters at index 0. So this here solves for this condition, right? Z is larger than all of them, so we return that. Let's look at this. Target is C, right? larger than C. Well, this is F. The ones larger than D, well, it will be F. So let's see if this works. Voila, it works, right? So, but since this is sorted, you could be asked to follow up to do it in log n time, right? And it is possible to do it in log n time using binary search modification, or what some call binary search variants, right? So all we do is we try to determine the portion of the array or the interval of the array which will contain the smallest. We will try to get the interval which will contain the largest characters, or characters larger than our target, right? And then when we get that portion, we'll get it after the binary search has ended. And then we return the index of I being our left pointer, because once the binary search ends, I becomes greater than j, right? So let me show you what I mean. Let me first show you in the drawing. So our characters are sorted, right? So we have A, B, C, D, right? Actually, let me make it A, B, C, E, and then F, and then G. And then we're told to find the target, D. Right? In other words, the character, the smallest character that is larger than D. Here we can see that it's E, right? But how do we find it? We use 2 pointers, one here and one here, and we do binary search. So in this case, once the binary search is over, this I will be at this position, and this J will be at this position, right? And then we'll return letters at I. And why is it will be at this position? It will be at this position because when we use binary search, instead of saying, say, letters at mid is equivalent to the target, we'll be saying letters at mid is less than or equal to target. Because we don't want, since we're looking for the larger, we're trying to get rid of the portions. So for this, we'll be getting rid of these portions, right? Or if letters at mid is greater than target, we'll be getting rid of portions of the array that do not fit our question, right? We're trying to remain just with this portion, right? So let me show you how we write that in code, right? So this is the binary search solution using a modified binary search. So we have our I pointer, our J pointer is equal to length of letters minus 1. And then we say while I is less than or equal to J, we calculate our mid, which will be I plus, in brackets, J minus I divided by 2. Remember, the alternative, but which may cause integer overflow options, is that. So now that we have the mid, we check for the portion, we check to get rid of the portion of the array that doesn't satisfy our problem. i.e., we want only those characters in the array that are larger than target. So if letters at mid is less than or equal to target, then we don't want any values at or before mid index, right? So we push our I is equal to mid plus 1. Else, we don't want any values at or next to, at or after the mid index. So we push our j to mid minus 1. So once this is done, this terminates when I becomes larger than j, right? And once I becomes larger than j, automatically, right? I'm going to, let me draw it here. Once I becomes larger than j, right? So we had our C, our F, and J, and our target was A. We started our I here, our J here. Once we're done with the binary search, we know that our answer should be here, right? So what will happen is our I will remain here, and our J will be here, right? So that's for this one. In another case, and we simply return I, right? The index, the value at, we return letters at I. Another case would be similar to what I showed you before, which was A, let's say C, let's say F, let's say G, and then we're looking for D, right? If we start our I here and our J here, after we're done with the binary search, our I will be here, and our J will be somewhere on the left side, this side, right? And then we'll return letters at I, right? So we return letters at I, and voila, it works. But this does not work for the test case for the wraparound, right? And let me show you. So if Z is A, B, J, D, and our target is Z, it doesn't work, right? Oh, sorry, I made a mistake here. J, I, J, K, L. It doesn't work, right? You know why? We have to do modulus length of letters, right? Voila, it works. You know why? Simple. If when this I, after we're done with the binary search and the I gives us the value, right? We're at 0, 1, 2, 3, right? In order to find out I modulus the length of this array, which in this case is 4, will give us I, right? But once I goes out of this loop, because that case can also happen, right? Where I has gone out of the loop. And this case happens when all these are larger, are smaller than z. In other words, there's no larger value, right? There's no larger character. So here we can have the example of A, B, E, F, A, B, E, F, L. And our target is Z, right? So for this case, what will happen is our I will terminate after searching for all, and it will end up here, right? Our J will be somewhere this side. So that will mean that this is when we consider the wraparound. The wraparound which I showed you was, we now consider this Z to be, we consider this to be like this: A, B, E, F, L, and with a Z, and it wraps around like this, meaning that A is larger and all these are larger, so L is the smallest. So the way we account for that, and that's why our solution wasn't working for that, is by doing modulus. And what modulus will do is it will give us, for this test case, it will be, so this is 0, 1, 2, 3, 4, 5, right? This now I is at 5, right? So it will be I modulus the length of letters, all right? This will be the position. I will give us this position here, which will be, in this case, I5 modulus the length of the array, which is 5, which gives us 0, right? So it will give us back this, right? It will be letters at index 0, which is what we did for the linear time solution, if you remember, right? So if you've understood, then this is the log n solution, right? So now I'm going to do a trace, but actually the trace isn't even necessary here. Like, this is a modified binary search. Once we're done with the binary search, it will always end up in the right, the smallest, if you want the smallest number greater than the target, it will be I. The J will be the largest number smaller than the target. All right. So that is our solution, and thank you. Bye.